Ever wonder why a cup of coffee slides off a dashboard when the car suddenly stops? Or why it's harder to push a full shopping cart than an empty one? These everyday phenomena have their roots in something fundamental to our understanding of the universe: Newton's laws of motion. First up, we have Newton's first law of motion, often referred to as the law of inertia. This law states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. Think of a soccer ball on a field. Unless a player comes along to kick it or a gust of wind blows it off course, it's not going anywhere. The key takeaway from this law is the concept of inertia, the inherent resistance of an object to any change in its state of motion or rest. This is why your coffee cup slides off your dashboard when you hit the brakes. The cup, initially at rest, wants to stay at rest, and when the car moves, the cup is left behind. Next is Newton's second law of motion, which explains how the velocity of an object changes when it's subjected to an external force. This law states that force equals mass times acceleration, often written as F equals sine ma. This means the force applied to an object is directly proportional to the mass of the object and the acceleration that's produced. To simplify, the heavier the object and the faster you want it to move, the more force you'll need. This explains why pushing a full shopping cart is more challenging than pushing an empty one. The full cart has more mass, so it requires more force to achieve the same acceleration as the empty cart. Finally, we come to Newton's third law of motion. This law states that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude, but in the opposite direction on the object that exerted the first force. Think of it like this. When you jump off a boat, you push down on the boat, and in turn, the boat pushes you forward. The force you exerted on the boat and the force the boat exerted on you are equal in magnitude, but opposite in direction. In summary, Newton's laws of motion explain the relationship between a body and the forces acting upon it, and its motion in response to those forces. The first law describes inertia, the second law relates force, mass, and acceleration, and the third law explains action-reaction. These laws together form the bedrock of classical physics, helping us understand and predict how objects will move under various conditions. So the next time your coffee slides off the dashboard, or you're struggling with a heavy shopping cart, remember, it's all just Newton's laws at work.